Hi class, this is lesson 1-7, find perimeter, circumference, and area. Our big question here is how do you find the area and perimeter of a figure? So this is a little longer lesson. We're actually going to split it up into 2 days. This first video here will only have the first page of notes on it because we'll just be doing the first page. So example 1. Example 1 right here, find the perimeter and area of a rectangle. So here's my rectangle. It says tennis. The inbounds portion of a singles tennis court is shown. Find its perimeter and area. So our perimeter for a rectangle we know is 2 times the base plus 2 times the height. That's one of the things. Here's my directions. Find its perimeter and area. And then an area for a rectangle is the base times the height. So my perimeter is 2 times, well, this 27, there's my base, and this 78, there's my height. So 2 times 27 plus 2 times the height is 78. So if you simplify that, you just put it in your calculator, you find the perimeter is 210, and that unit would just be plain feet. So there's my answer right there. And for the area, base times height, my base is 27 and my height is 78. So if you multiply those together, you get 2,106, and my unit would be feet squared. So here's my area. My extra example 1, it'd be a good idea to pause it and try this one on your own. Okay, it says the length of a rectangle is twice the width. If the width is 25, what is the area? Okay, so there's a little bit more to this. Here's the key sentence though. The length of a rectangle is twice the width. We know we have a rectangle, so I'm going to draw my rectangle. And I'm going to make it so my length looks like it's 2 times my width. So I could make the sentence length is twice width. And if you change that from a sentence in English to a sentence in math language, you could put L equals twice, means 2 times, the width is W. So if we think of this as our length and this is our width, we know for length, instead of W, we can put, or instead of L, we can put 2W. It says the width is 25, so this side is 25. And we know my length is twice that, so 2 times 25 is 50. So I know I have a width of 25 and a length of 50. It says what is the area? So for area of a rectangle, that's base times height, or that's really length times width. So we're going to say 50 times 25, which is 1,250, and we don't have a unit, so we're just going to say units squared. Alright, let me move this up so I can see the next examples. The next 4 examples, really. Okay, and this next one, example 2, find the circumference and area of a circle. So we know we're going to have a circle, so I'm going to draw my circle in here. Not perfect, but that's okay. It says archery. The smallest circle on an Olympic target is 12 centimeters in diameter. Sorry, that's my puppy being noisy. Find the approximate circumference and area of the smallest circle. So we're going to say that's our smallest circle right there. And it says right here that 12 centimeters in diameter. So all the way across this, it's not the perfect diameter, it should go right through the middle, is 12 centimeters. And it says find, here's the directions, find the approximate circumference and area. So circumference for a circle is, well, 12 is my diameter, so I'm going to use the circumference that deals with diameter. Circumference is pi times my diameter. So my circumference really is 12 pi, and that's centimeters. And if you want to put that in your calculator, 12 pi is what we call an exact value because there's no rounded amount there. But putting 12 times pi, use the pi button, not 3.14, use the pi button, It's 37 7/10 centimeters. And there's my answer right there. We also need to find the area of our circle. Sorry if you can hear my puppy. Area is pi times our radius squared. Now I know 12 is my diameter, so my radius would be just halfway across. Half of 12 is 6, so I have to use that as my radius. So it's pi times 6 squared. Well, 6 squared is 36 pi, so we could say 36 pi centimeters squared. That's our exact value. And if you want a rounded value, put it in your calculator and you'll find your area is about, if you do 36 times your pi button, again, don't use 3.14, use your pi button, you get 113.1, and my units is centimeters squared. Alright, this next problem right here is the extra example, so pause it and try it on your own. It says find the approximate circumference and the area of the circle, so we're doing the same two things we used here, but this is a formula for circumference using diameter. We have our radius here, so we're going to use our other formula, pi r squared. So I'm going to say circumference is... I just said pi r squared for circumference. I was wrong. It's 2 pi times the radius. That's my circumference. So circumference is 2 pi times 8, which is 16 pi meters. That would be our exact value again, because there's no rounding involved. But if I want to round it, if I put 16 times pi into the calculator, you find that that's about 50 3/10 meters. And that is your answer right there. I would be perfectly fine with you putting 16 pi though as well. It's something we use more in GOB, and something you need to know how to do is find exact values. So the area of this is pi times my radius squared. So area is pi times 8 squared, and that's 64 pi. Should be a squared sign there. 64 pi meters squared. Or, if you again put it in your calculator and get your rounded value, it's about 201 1/10, and that would be meters squared. Alright, example 3 here. Example 3 is triangles. We're going to move into our triangles. The area of a triangle is 66 meters squared. Find the height. So, for a triangle, this is a formula you've been working with for a while. The area of a triangle is base times height divided by 2. Now, in here, we can see our height is right here, but the part on this one that gets confusing is the base is just this bottom part of my triangle. Even though the height is over here outside of the triangle, the height always has to be at a right angle to the base, so sometimes we have to extend the base outside of the shape. See how right here my base is extended? This is not part of the triangle. So that piece right there, that 7, we don't want to use that. We're going to use this 12 right here as our base. So let's go ahead and plug in the numbers that we were given. Our area, it says, is 66. I'm going to plug 66 in here. My base is 12. My height is h, and I'm going to divide that by 2. So if I multiply both sides by 2 here, 66 times 2 is 132 equals 12h. Divide them both by 12. And 132 divided by 12 is 11. So my height is 11. Looks like 111. My height is 11. So the answer, the height is 11, and that would be meters. Pause it, try the next one on your own. Okay, this problem right here, it says find the area. So I know I'm going to use this A, that's what I'm going to be looking for, and I'm going to use the same formula because just looking at the shape, it's a triangle, and I see the word triangle right here. Find the area of the triangle shown at the right. So we need a base and a height here. And looking, I can't count how long that is. I can't count how long this side is. I could use my distance formula, but there's an easier piece. I can count how long this side is right here. So for that side, right here, that's 3 units. So I'm going to use that as my base. And now just like this example problem over here, sometimes our height is outside the triangle. What I would need to do is extend this base, and I need to find this perpendicular height right here. So from here over to here, this is actually my height. For some of you, it might help to turn your paper a little bit. And that's 1, 2, 3, 4, 5, 6. So my height is 6. So my area of this triangle is base times height divided by 2. So the area is 3 times 6 divided by 2. That's 18 divided by 2, and my area is 9. And I don't have a units here, so I'm just going to say units squared. That's my area. This is the end of the notes for the first lesson of 1-7. Have a great day.